I'm Gloria. I work on Bitcoin Core at Brink. And today I'm going to talk a bit about mempool policy and why you cannot always expect your transactions to propagate or your fee bumps to work, but what we're doing to try to resolve stuff like that. So this talk is for those of you who find the mempool a bit murky, or unstable or unpredictable, or you're not really sure if it's an interface you're comfortable building an application on top of. For me, I would guess that that's most of you. And hopefully today we can make the mempool a bit more clear. So my goal is to be as empathetic as possible when it comes to transaction propagation limitations. I'm going to try to bring a perspective of a Bitcoin protocol developer, how we reason about mempool and transaction relay. I'm going to define what policy is, how we think about it, why we have certain policies, and define pinning. I'll go over some known limitations that we have, maybe clear up some misconceptions about what attack vectors are possible. I'll mention a specific lightning attack. And my goal is for us to walk out of this today as friends, so we can start a conversation about how to build L1 and L2 with a seamless bridge between them. Okay, so I want to start off from the ground up to make sure that we're on the same page about how we think about Bitcoin. So we want Bitcoin to be a system where anyone in the world can send money to anybody. That, I think, is the whole point. So abstractly, people often use the terms like permissionless and decentralized and trustless, but perhaps a slightly more concrete framework would be something like this. So, oops, what just happened? Okay, I just sneak peek of what the framework is. But the first point is we want it to be extremely accessible to run a node. So if, for example, Bitcoin D doesn't build on macOS, or it requires 32 gigs of RAM, or it has $2,000 a month of running costs in order to operate a full node, that's unacceptable to us. We want it to run on just your basic Raspberry Pi easy hardware. Okay. And the other part is censorship resistance, because we are trying to build a system that works for those for whom the traditional financial system has failed. So if we've built a payment system where it's very easy for some government or wealthy bank or large company to censor arbitrarily transactions from users that they don't agree with, then we have failed. The other thing is we want it to be secure, obviously. So this is an arena where we're not relying on some government where we can see, oh, this node, which corresponds to this real-life identity, did something bad, so now we go and prosecute them. We don't have that option. We want anyone to be able to run a node. That's part of the permissionless and decentralized portion of Bitcoin's design goals. Therefore, security is not an option. It's first and foremost when we're designing transaction relay. And fourth, also relating to permissionlessness and decentralization, we do not force software updates in Bitcoin Core, right? We cannot force anyone to run a new patch of Bitcoin node. So if we were to, say, have an upgrade that improves user privacy, but it costs way more, or miners are going to lose 50% in revenue and fees, that we cannot reasonably expect anyone to upgrade their node to that software. So incentive compatibility is always in mind when we're talking about transaction relay. So this is kind of the baseline framework for how we're thinking about things. Hopefully this does not come as a surprise to you, but the way that we deal with this is in Bitcoin we have a distributed peer-to-peer network where hopefully anyone can run a Bitcoin node, connect to the Bitcoin network, and that comes in many forms. It could be a background task of Bitcoin D running in your laptop. It could be a Raspberry Pi that has Umbrel or RasBlitz installed on it. It could be a large company server that's servicing thousands of smartphone wallets. All of them might be a Bitcoin node, so they look very different, but on the peer-to-peer network, they all look just like a Bitcoin node. And so when you're trying to pay somebody, all you do is you connect to your node, you submit your transaction, you broadcast it to your peers. Hopefully they will broadcast it to their peers, and then it'll propagate, eventually reach a miner, and they'll include it in a block, or miners. Yeah, so One really key part of transaction relay, everyone who participates in transaction relay keeps a mempool. I'll define what a mempool is for those of you who want it defined. It is a cache of unconfirmed transactions, and it's highly optimized to help pick the sets of transactions that are most incentive compatible, aka highest fee rates. And this is helpful for both miners and non-miners. This helps us gracefully reorg. It allows us to design transaction relay in a more private way because we're doing something smarter than just, accept and then forward. So it's useful. I've written extensively on why mempools are useful if anyone wants to read more. You may have heard the phrase, there's no such thing as the mempool. And that is true. Each node keeps a mempool, and each node can have different software, and they're allowed to configure it however they want, because in Bitcoin is freedom, right? And so different mempools might look different. Your Raspberry Pi 1 might not have as much memory available to allocate for the mempool, so you might be more restrictive in your policies. Whereas a miner might keep a very large mempool because they want a very long backlog of transactions that they can include in their blocks if things empty. So we refer to mempool policy as a node set of validation rules for transactions in addition to consensus, which all unconfirmed transactions must pass in order to be accepted into this node's mempool. So again, this is unconfirmed transactions. It has nothing to do with transactions within blocks. It's just their prerogative what they're going to restrict coming into their mempool. Okay. I want to really hammer in the point that from a Bitcoin protocol development standpoint, we're trying to protect the user who is running this Bitcoin node. I get into a lot of fights with application developers who think we should be protecting the user who is broadcasting the transaction. And in some cases, those two are, they're not aligned, we'll say the least. And so we have an extremely restrictive set of resources available to us in mempool validation. Typically, it's just 300 megabytes of memory. And we don't want to be spending, for example, even half a second validating a single transaction. That's too long. So once again, even though we are trying to support the honest users, the whistleblowers, activists, the traditionally censored people, we also need to be aware that when we are connecting to a peer, by design, we need to expect that this peer can be an attacker. So the most common thing that we think about is CPU exhaustion. So again, if it takes half a second, that's too long to validate a transaction because we'll have hundreds of transactions coming in per second, right? And so if, again, our code is open source, so if there is a bug in our mempool code such that you can cause an out-of-memory error because of some transaction with a specific type of script, for example, we need to expect that that's going to be exploited. Excuse me. So another thing to note is in the competitive world of mining, it might sometimes be advantageous for a miner to try to fill mempools with garbage or render other miners' mempools useless or try to censor high-fee transactions from their mempools. Or maybe they're launching a long-range attack where they put things in the mempool such that when they broadcast a new block, everyone has to spend half a second is too long, updating their mempool or flushing, just whatever it is. They stall the network for half a second, and that gives them a head start on mining the next block, which is significant, or they're able to launch some other type of attack. Okay. And the other, why isn't it working? Okay, there we go. The other concerns that I will talk about less today regarding privacy and well, actually, I will be talking a lot about Lightning counterparties, but we are also aware of the fact that Lightning counterparties with conflicting transactions might have a back and forth with respect to fee bumping races or pinning attacks, and we want to make it such that as long as the honest user is broadcasting something incentive compatible, they're always going to be able to win. always, most of the time, let's say. And of course, transaction relay is an area where privacy is a huge concern, because if you're able to find the origin node that a transaction came from, and you're able to link an IP address with a wallet address, it doesn't matter how much you hide on chain, you've already de-anonymized this transaction. So this is an area where privacy is a huge concern. And the other example of this is transactions are probably the cheapest way to try to analyze network topology. So we're always trying to make sure we're not shooting ourselves in the foot with respect to privacy. Again, I'm not going to talk about privacy as much today, but it's also a concern. Okay. So we can kind of think about policy on a spectrum where on one extreme end, we have the quote-unquote ideal perfect mempool, where we have infinite resources. We're able to freeze time every time we receive a transaction or need to assemble a block, and we have infinite amount of time to validate or assemble. And perhaps in this case, we accept all consensus valid transactions. On the other side of the spectrum, we have the perfectly defensive conservative mempool policy, where we don't validate anything. We don't want to spend any validation resources on anything that comes from someone we don't know. Unfortunately, if we want to make this sustainable at a network level, we're going to need like a central registry of identities that correspond to nodes or wallet addresses, and we're just a bank at that point. So this neither end of the spectrum really follows our design goals that we want. So really we want to be somewhere in the middle. But it would be too easy if this was the only concern, right? DOS protection is actually not the only thing that we think about when it comes to mempool policy. That's a common misconception. So let's go back to thinking about these two ends, and we'll see why this kind of linear approach is not the full picture. So even if we were to have infinite resources, would we want to accept every single consensus valid transaction? The answer is actually no. So the best example I can offer is Softforks. So while we have this space of all consensus valid transactions today, that space can shrink. And so with the recent Taproot activation, for example, we noticed that F2Pool, who mined the activation block, did not actually upgrade their nodes to have Taproot validation logic. Boo. And so the question is, what would have happened if somebody sent them an invalid Taproot spend, like an invalid version 1 witness spending transaction? Well, if they had accepted that into their mempool and mined it into a block, then F2Pool and Pool and all of the users with nodes that weren't upgraded would have forked. And we would have a network split where some of the chain is like not upgraded and some of it is actually enforcing Taproot. This is disastrous, but as long as 51% of the hash rate is enforcing Taproot, we're okay. But this is a very bad situation that we would want to avoid. So presumably, all miners were running at least version 0.13 and above, which included SegWit. And with SegWit, which had semantics for version 0 witnesses, it discouraged the use of all witnesses version 1 and above. So that's why F2Pool did not enforce Taproot rules, but they also did not accept any version 1 witness transactions into their mempool and did not include those in their blocks. So this is one reason why this kind of linear view is imperfect. On the other side of the spectrum, we have the perfectly defensive one. So the question is, are there policies where we are trying to protect the node from DOS, but we harm users? So this goes back to all those conversations I've had with application devs where policy is kind of harming their users. So the example here I'm going to give is the descendant limit. So in our mempool, we have a rule, or sorry, when I say our mempool, I mean Bitcoin Core standard NIST rules, the defaults. The default limit for descendants is you won't allow a transaction and all of its descendants in the mempool to exceed 101 kilovirtual bytes. And this is a sensible rule because you can imagine, let's say, a miner is broadcasting transactions such that everyone's mempool is one transaction and then descendants. And then they publish a block that conflicts with that transaction, and they've just flushed out everyone's mempools. They spend, like, I don't know, a few seconds updating all those entries, and then now they have an empty mempool, and they have nothing to put in their next block, and this miner just got a head start on the next block. So this is a sensible rule in protecting our limited mempool resources. However, for Lightning devs out there, perhaps you are aware of this, when anchor outputs were proposed in Lightning, so the idea was each counterparty would have an output in the commitment transaction that could be immediately spent, so that each of them could be attaching a high fee child to fee bump the commitment transaction. So that was the background behind anchor outputs. It was a great idea. However, they were thinking, okay, what if one of the counterparties dominates the descendant limit? So they broadcast a 100 kilovirtual byte child, and now the other counterparty is not able to fee bump. And this is what is known as a type of pinning attack. So a pinning attack is a type of censorship attack in which the attacker takes advantage of mempool policies to either censor a transaction from mempools or prevent a transaction that is in the mempool from being mined. So in this case, they're preventing the commitment transaction from being mined. Cool. We've defined pinning. Okay. It's noteworthy, I think, to mention the CPFP carve-out exemption, which was shoehorned in to mempool policy to address this exact attack on Lightning users. So it's a bit convoluted. If the extra descendant has a maximum of 2 ancestors in their ancestor limit and it's within 10 kilovirtual bytes and then they get an exemption. It's the cause of a lot of testing bugs, and it's an ugly hack. I'm not here to complain, but what I want to note is that the average Bitcoin node user who maybe doesn't care about Lightning or for whatever reason doesn't really have a reason to have this in their mempool policy. It might not be entirely incentively compatible is what I'm saying, and I'll come back to this later. Cool. All right, so speaking of fee bumping, I do want to mention some examples of policies that people might like. So these fee bumping primitives are all brought to you by mempool policy. So the first one is RBF, and this comes from a behavior in our mempool where if we see a transaction that conflicts with something in our mempool, we're not just going to say, oh, we don't want that. We'll actually consider that new transaction, and if it pays significantly higher in fees, we might replace the one in our mempool. So this is good for users because for incentive compatibility, it aligns and it allows users to fee bump their transactions. The other one is the mempool is aware of ancestor and descendant packages. So when we're including transactions in a block, we'll go by ancestor fee rate. This allows a child to pay for a parent or CPFP. And when we are evicting transactions from the mempool, we're not going to evict something that has a low fee rate if it has a high fee child. So again, this is incentive compatible, but it also helps users. And I'm going to show my work really quickly. Package RBF is the combination of RBF and CPFP such that you can have a child paying for both its parents and RBFing the conflicts of its parents. It's pretty cool, you should check it out. Okay, so just to summarize what we've covered so far, we've defined mempool policy as a node's set of validation rules in addition to consensus that they apply to unconfirmed transactions in order to be accepted into their mempool. We've covered a few different reasons for why we have mempool policy. One of the biggest ones is DOS protection. We're also trying to design a transaction acceptance logic that is incentive compatible. And it allows us to upgrade the network's consensus rules in a safe way. And there's a fourth category that I thought I'd mention, but we don't have time today, which is network best practices or standardness, such as the dust limit, such as, I won't get into it, but that's the one that I think is more miscellaneous, let's say. Okay, so I did title this talk Transaction Relay Policy. And it's because we're aware of the fact that the vast majority of nodes on the Bitcoin network run Bitcoin core nodes. And the vast majority of people who respond to polls on Twitter have stated that they use the default settings when it comes to mempool policy. And this is kind of scary when you're opening a PR for mempool policy changes, but it is a good thing in that it allows us to kind of have a set of expectations for whether or not our transactions are going to propagate across the network. So it might be called transaction relay policy. Okay. Now I'm going to get into known issues with our default mempool policy in Bitcoin Core. I've been told that a lot of policies seem arbitrary, such as the dust limit, for example. And I want to empathize, and that's why I made this meme to show my sympathy. But yes, essentially, as an application developer, you don't have a stable or predictable interface for broadcasting your transactions. And especially in Lightning or off-chain contracts, where you're relying on being able to propagate and confirm a transaction in time to redeem the funds before your counterparty gets away with stealing from you, this can be a huge headache. So I'm it keeps skipping. Okay, so I'm aware of some within the standardness of a transaction itself. So the biggest one is the dust limit, and the myriad of like script, convoluted, opaque script rules that transactions need to follow. And another category is transactions and evaluation within the context of a mempool. So I already mentioned very niche exceptions in ancestor-descendant limit counting. I'm also aware of BIP125 RBF giving a lot of people grief because it could be expensive or sometimes even impossible to bump your fees, fee bump your transactions using RBF. And of course, I think one of the biggest ones is in periods of high transaction volume, which you never know when that is going to happen, you're not always able to fee bump your transactions. I put at the bottom, the worst one is that every mempool can have different policies. I would say another one is that mempool policy is not well understood, I think, by application developers, and that's why I'm here. Okay. I'm going to now describe a specific Lightning channel attack, and it all stems from this fact that commitment transactions cannot replace each other. So in Lightning, you have this combination of conditions where you negotiate the fee rate ahead of time, way before you're ever going to broadcast this transaction because you weren't planning on broadcasting that transaction. And you're also not able to use RBF because if your counterparty is trying to cheat you or you're doing a unilateral close because they're not responding to you, they're obviously not available to then sign a new commitment transaction with you. But also, because mempools only look at replacement transactions one at a time, and your commitment transactions are going to be the same fee rate, because why wouldn't they be? Commitment transactions cannot replace each other. So even if TX2A has a huge fee rate, TX1 cannot replace TX2. TX1A cannot replace TX1B. Small note, I'm aware that these are not fully encapsulating all of the script logic in Lightning transactions. Please bear with me. Like the revocation keys and stuff I didn't include, but just imagine these as simplified Lightning transactions. Okay, so we're going to describe an attack between Alice, Bob, and Mallory, where Alice and Bob have a Lightning channel, and Bob and Mallory have a Lightning channel. So Alice is going to pay Mallory through Bob, because Lightning. And if Lightning is working properly, either both Bob and Mallory get paid, or neither of them gets paid. That's how it's supposed to work, right? So the spoiler here, oh, okay, wait, no, hold on, sorry, I got ahead of myself. So when the HTLC is offered from Alice to Bob and from Bob to Mallory, each one of them is going to have a transaction in each channel. So there's going to be a pair of transactions, a pair of commitment transactions in each channel. In LN penalty, we have kind of these like asymmetric commitments so that we're able to attribute blame for who broadcast the transaction, right? So cool. These are conflicting transactions. Just to be clear, TX1A and TX1B conflict, TX2B and TX2M conflict. So only one of them can be broadcast and confirmed on chain. Cool. So we've constructed this such that Alice is paying Bob, and Bob is paying Mallory. Mallory can reveal the pre-image to redeem the funds, or Bob can get his refund at T5. On the other side, Bob can reveal the pre-image that he got from Mallory and redeem the funds, or Alice can get her refund at T6. And so Bob has that tiny little buffer timing out between Mallory not paying and Alice redeeming. But, spoiler alert, the outcome of this attack is going to be Bob pays Mallory, but Alice doesn't pay Bob. So these would be the corresponding transactions where Mallory broadcast, and then she got the redemption with the pre-image, and Alice broadcast where she got the refund from Bob. And it's going to happen such that at T6, Alice gets her refund, but Bob was not able to get his refund. Cool. So let's rewind back. This is the spoilers. I was just trying to show you the outcome first. Okay. So what happens is Mallory broadcasts her commitment transaction with a huge pinning transaction attached to it at T4. Now, these two transactions are in everyone's mempools. So there's two scenarios. Either Bob has a mempool and is watching and knows that Mallory broadcasts these transactions, or he doesn't. So let's go over the first scenario first. We require CPFP carve-out. But like I said before, I don't really know why every mempool would have CPFP carve-out implemented as one of their mempool policies. It allows Bob to get his money back in this case, where he's able to fee bump the commitment transaction, and then he gets his refund. But in this case, CPFP carve-out is critical to Lightning security. The second case is Bob doesn't have a mempool. I think this is a more reasonable security assumption for Lightning nodes, because it just doesn't make sense to me that Lightning nodes need to have a Bitcoin mempool or to be watching Bitcoin mempools in general. So Bob was not watching the mempool, or a mempool, let's say. And so at T5, he says, okay, Mallory hasn't revealed the pre-image to me, so now, and she's not responding to me, so now I'm going to unilaterally close. I'm going to broadcast my commitment transaction plus a fee bump, and I'm going to get my refund after the 2-self delay. The problem is, because Mallory's transactions are already in the mempool, even if Bob broadcasts it, and he's like, okay, why isn't it confirming on chain? Like, he's watching the blockchain and he's not seeing his transactions confirm, and he's very confused. It's because Mallory has already put this transaction in the mempool and he's not able to replace it. The solution to this is package relay. And so in this case, package relay is an important part of Lightning security. Okay, so in both of these cases, T5 has elapsed, and Bob has not been able to successfully redeem his refund from Mallory. And so I already showed this portion. At T6, Alice gets her refund, but Bob didn't. And so in this case, Mallory has, so let's pretend that Alice and Mallory are actually the same person. So they've managed to steal this HTLC amount from Bob. Okay, hopefully everyone followed that. Okay, just as a disclaimer, this is easily avoided if the commitment transactions were negotiated with a fee rate that was high enough to just confirm immediately in the next block at T4 or T5. And this brings me to my recommendations for L2 and application developers. My recommendation is to, for the time being, lean towards overestimating on fees rather than underestimating, because again, these pinning attacks only work if you're like floating at the bottom of the mempool and you're not able to fee bump. Another one is never rely on zero confirmation transactions that you don't control. What you have in your mempool does not necessarily match what miners have in their mempools, or even like the entirety of the rest of the network might have a different transaction in their mempool, for example. So if you don't have full control over that transaction, don't rely on it if it has no confirmations. Another one is there's a very nice RPC called Test Mempool Accept, available with Bitcoin Core, and that will test both consensus rules and standard Bitcoin Core default policy. And again, because that's so prevalent throughout the network, or that's the vast majority of policies throughout the network, it should be pretty good for testing. So especially if you're relying on fee bumping working, recommend having different tests with various mempool contents, maybe conflicts, maybe some set of nodes, to test your assumptions. Try to do that on every release, maybe on master every once in a while. I don't want to put too many expectations on you, but these are my recommendations for how to make sure that you are not relying on unsound assumptions when it comes to transaction propagation. And I would like to invite you to communicate your grievances, whether it's with our standard mempool policy or it's with the testing utilities not being sufficient for testing your use cases. Just please complain and say something. And hopefully this talk has convinced you that while we do have restrictions for a reason, we want to support Lightning applications. And please give feedback on proposals when they're sent to the Bitcoin Dev mailing list. On the other side, I think we all agree that Lightning transactions are Bitcoin transactions. So at least in the Bitcoin Core world, we want to be documenting, one big effort is to document our current transaction relay policy and provide a stable testing interface for passing in transactions to make sure that they're passing them. We are also working on various improvements and simplifications of our current mempool policy. And recently we've agreed not to restrict policy without notifying Bitcoin Dev first. But of course, that doesn't work unless you guys read Bitcoin Dev and then give us your feedback if something is going to harm your application. So I think together we can make privacy and scalability and all of those usability wonderful things that come with L2 applications without sacrificing security. Thank you. Any questions? I'm available for questions. Yes.
With Test Mempool Accept, you said it was hard-coded to the default policy, or is it based on the policy that I'm running on my node?
Oh. Okay, so if you're calling Test Mempool Accept on your node, it'll be your node's policy. But if you say spin up some regtext nodes, or you just compile Bitcoin D, and then that'll be whatever the defaults are.
Gotcha. So it's not the default, it's whatever my node is running. So if I want to test other assumptions, I could change the policy on my node, and then that would be reflected in Test Mempool Accept.
Yes.
Awesome. Thank you.
Yes. Any other questions?
Would, if the package relay makes it in, would that allow us to safely remove the CPFP carve-out in the future without harming people with existing Lightning channels and stuff like that?
That's a very good question. I think so, but I haven't completely thought it through. But I think so. Yes.
Just one question regarding the Lightning nodes actually monitoring the mempool or not, right? So you said that you thought a Lightning node, I mean, it was not a proper assumption to think that a Lightning node would be monitoring the mempool, because why should it? But if you're actually forwarding HCLCs and someone may actually drop the community transaction on chain, and you may see the secret there, and you have to like actually claim your accept HCLCs with the same secret. Why would you wait for that transaction to get confirmed instead of taking that from Mempool? I mean, you shouldn't assume that you're going to receive that on Mempool because you may not. But if you see it on a Mempool, you may be able to act quicker, right?
Right. So I think this is how I'm understanding your question, is in a lot of these types of attacks, if like the honest party is watching the mempool, then they're able to mitigate that attack and respond to it. So I think it's a difference between having a mempool helps and mempools are required in order for Lightning nodes to be able to secure their transactions. So yes, on one hand, I do agree, having a mempool helps, but I don't think anybody wants a mempool to be a requirement for Lightning security. Does that make sense?
And even then, it will be a monitoring of the entire mempools of the network, which is not possible.
We're missing a speaker, so that Paul from Sphinx was going to come and do a session now. So Antoine, you want to go in, and we'll keep going with the Q&A, and you guys can brief.
Okay, so we're just gonna talk.
Yeah, improvised Q&A. Hopefully there are queues. Oh, we take questions, right?
Oh, there are questions. Yes.
What's the story on you and Lisa with the death to the mempool thing?
Okay, so I'm happy.
We got some time by the sounds of it.
So I'm happy to talk about this offline.
Okay.
So Lisa and I had a discussion about it where we disagreed with each other. And she tagged me in her post to the Bitcoin dev mailing list. And I think people were under the impression that our discussion was us being in agreement when actually we didn't agree. So I think that's where most of the confusion comes from.
In her stance is that mempools are just unreliable, so we should get rid of them altogether? Or?
Right. So so mempools as they stand today are not perfect. It's not an extremely stable interface for application devs. So I've heard multiple Lightning devs say, for us, a much better interface would just be if we were like buddies with like if our company partnered with a miner and we were always able to submit our transactions to them. So like, for example, all LND nodes or all Rust Lightning nodes were able to just always submit to L2 pool or something, and like that would resolve the headaches around making sure your transactions are standard and you're going to meet policy. I understand why that's more comfortable for Lightning devs, but I feel like in that case, it's not, oh, we need a mempool in order for Lightning to be secure. It's we need a relationship with a specific miner in order for Lightning to be secure. And I don't think that's censorship resistant. I don't think that's more private. I don't think that's the direction that we want Bitcoin and Lightning to go in. Again, that's my own personal opinion. But like that's why I came today to talk about this, because I understand there are grievances, but I think we can work together to make an interface that works.
And at the end of the day, it's pretty similar to what I said with fee bumping. You have shortcuts, you have easier passes, and very often they would increase centralization pressure. And once we lose censorship resistance, we will realize that it was precious, and we should think before we lose it.
I can ask.
There's a question there.
2 weeks.
I can't offer a specific roadmap, but I can tell you what is implemented and what is yet to be implemented. So all of the mempool validation code is implemented. It's not all merged, although I think we're closer. I'm not gonna make guarantees. So that part is already written. The next part is defining the P2P protocol, which we get closer to finalizing every day. So writing out the spec, putting out the BIP, implementing it, and then getting it reviewed and merged. So that's what's implemented and what's not implemented. So you can make your estimate on how long that will take in terms of human times.
So like 3 weeks then? 3 weeks. We'll give you an extra week, a spare week.
That would be really nice.
No problem. I had just a general question before I pass the mic over there to some Felix guy or whatever. But while you've been working on Package Relay and your effort over this time, what have you learned that surprised you? Or if you just want to share maybe something that's interesting that was unexpected, something more difficult or more easy than you thought, or something that you've learned that has been interesting?
That's a good question. I'm surprised by how fun it is. It is a privilege every day to wake up and get to think about graph theory and incentive compatibility and DOS protection, and it's very fun. I didn't expect it to be this fun. But a next layer of surprise is I'm very surprised that not everyone is interested in mempool policy. Yeah.
Which is weird, right?
It's very weird.
Great talk, thank you. It was very fun and entertaining and informative. My question is, do you have some example of DDoS attack vectors that you would introduce that are not super obvious, maybe, when you have like a mempool package policy?
Yes. So, for example, our UTXO set is several gigabytes. So some of it is stored on disk, and we have layered caches. And we want to be very protective over what is like how peers on the peer-to-peer network can influence how we're caching things, because that can impact block validation performance. So for example, if based on how we limit the size of one transaction, we can expect like n churn in our UTXO caching system. We don't want that to be way larger if we are validating 25 transactions at a time, or 2 transactions at a time, or n transactions at a time. So that would be an example of a DOS attack. And same thing with like if there are like polynomially or exponentially more signatures that can be present in a package compared to an individual transaction, we don't want to be expending exponentially more resources validating a package compared to a transaction. Does that make sense?
Sure. Is there maybe, especially because the Lightning case is a very specific case where you have a package of like pretty much just 2 transactions. So is it maybe just trying to get that one right first and then think about the general case later?
Yes, so the single child, single parent versus single child, multi-parent. So I think most of it was a trade-off between complexity with implementation versus how useful it would be for both L1 and L2 protocols. And given the fact that we know there's a lot of batched fee bumping that happens even on like the on-chain Bitcoin level, it has a very high like usefulness score in terms of multi-parent single child. It has a very high usefulness score. And then when we were looking at single parent single child versus multi-parent single child, the complexity is not that much worse. And so, like, weighing those 2 things against each other, multi-parent single child was better on those 2 things.
and it seems a bit weird as well to tailor the mempool policy rules to a specific use case, that is Lightning. Kind of the criticism with carve-out, which I can agree with. MultiParent FBMP for CPFP could be useful for other applications as well, and is useful to other applications.
I'll go again if that's okay. So, you know, I agree with you that mempool is like actually a super interesting research area, and throughout, I mean, the entire kind of blockchain space, we've seen things blow up because of mempool policy, not necessarily in Bitcoin, but in other blockchain ecosystems. You know, do you spend much time just trying to you know, look through what other blockchains have tried and either failed at, and you know, there's plenty of examples of that, or maybe even succeeded at, that we could bring over to the Bitcoin mempool policy? It's a broad question, I guess, so feel free to answer however you want.
Do you want to go first? Okay, so to answer your question, no, I haven't spent any time. Not because I don't think there's good ideas out there. I think that's a really good point that, you know, I'm not the only person who's ever thought about a mempool, or Bitcoin is not the only place that's ever looked at a mempool. I have noted that a lot of the problems that we have in mempool are specific to the fact that we are a UTXO-based model. So it's nice because, for example, we don't have the problem where we aren't able to enforce ordering of transactions. It's trivial for us because parents need to be before children. But it does mean that when we are looking at, when we are creating a mempool, for example, actually 75% of the mempool dynamic memory usage is allocated for the metadata and not the transactions themselves, because we need to be tracking packages of transactions as a whole rather than treating them as atomic units.
Sorry, and that's in a package relay world, or that's in Bitcoin
In the
core?
Bitcoin world. Yeah.
Today, like with...
Yeah.
Okay.
Yeah, 75%.
That's surprising.
Yeah, it's always surprising to people. But I think it's mostly because of the fact that we have a UTXO-based model, which I don't think is a bad thing. This is just something that we have to deal with that other people don't have to deal with. And like I said before, there are advantages of this that we have that other people don't. Oh, did you want to answer the question too? Okay, sorry.
The question, if you couldn't hear this gentleman over here, was after Gloria finishes this in a prompt 3 weeks, which we are all now expecting her to finish this by, will she be then working on Dandelion? Did you have anything else, Dustin?
Yeah, I mean, for context, obviously Dandelion is mostly dead. Everyone's given up on it. But I'm just curious if you have any thoughts that you've gained from your insight working on this particular project into Dandelion. Maybe you could elaborate on anything. Do you have any insights at all? But I don't mean to put you on the spot that you do have any. Just I'm curious.
I'm aware of the fact that I'm standing on a stage and this is recorded, so maybe we can talk offline.
Okay, sounds great. Can we turn off the cameras? No, just kidding.
Question, was it?
No, I was done.
Is someone asking a question that I don't know about?
Are there any other areas of Bitcoin that you're excited about? Like, what's like your number 2 after package relays? Like, what excites you to think about? Is that also a question that I shouldn't ask?
It's a good question. I don't want to like put myself in a place where I have to work on something.
Is it Ethereum?
No, but.
If I can take this over, I would chill Miniscript. Miniscript is great, especially for application developers. Look into Miniscript, and yeah, Miniscript is very exciting.
Okay, I'll bite. One really big initiative that multiple people are working on is modularizing the code base, and one particular goal is to have like a consensus library, such that we can isolate that apart from everything else in Bitcoin Core, and then perhaps turn it into a library that other Bitcoin clients can use. I think a really big part of that is going to be untangling mempool and P2P logic from consensus. And that's pretty exciting.
Will there be a ELI 5 on Package Relay?
A what?
ELI 5.
Oh, I can explain that. So it's an acronym, it means explain like I'm 5. Thank you, I'm done speaking.
Oh,
For the plebs.
like I'm supposed to do it right now? Or?
Yeah. Like
Oh.
in about 4 sentences or less.
Okay. Can they be long sentences?
Yes. Run-on sentences are acceptable.
All right. Currently, in our mempool logic, we are limited to validating transactions one at a time, which is a restriction that doesn't allow us to accurately assess the fee rates of transactions. That was the first sentence. This means that in periods of high transaction volume where the mempool minimum fee rate is above, say, 1 Satoshi per VByte, if a transaction has a base fee rate below that, no amount of child pays for parent is going to be able to introduce that to the mempool. That was the second sentence.
You're like a typewriter. You keep going over there and coming back over. I love it, yeah.
Package relay, actually no, third sentence. Package Mempool Accept is the logic to introduce.
I mean, you got to do it now at this point. It's part of the meme of explaining now.
To introduce the mempool validation logic and policies to assess multiple transactions at a time as candidates for the mempool. Package relay is the P2P protocol change that will enable broadcasting packages of transactions between peers on the P2P network. 4 sentences.
Thank you.
Yes, John?
Hi, Gloria. That was a really great explanation of Package Relay in 4 sentences. But if I wanted to learn more about Package Relay, is there some place I could find out, like a podcast or something like that?
Oh, yes. So Brink has recently released a podcast called the Bitcoin Development Podcast. We have recorded the first 5 episodes, and it's all about mempool policy, pinning attacks, package relay, and mining improvements. I would recommend going to brink.dev/podcast to learn more.
Good answer.
Could you talk maybe a little bit about dust limit and mempool acceptance, or is that too much or can to ask today?
What's the question?
He wants to know about dust limits.
What do you mean?
Lowering the dust limit for mempool policy, is that on the roadmap? Should we have it? Should we not have it? Are there different clients that have different thoughts about what is the current dust limit? Because I think I had some channel closings because there were some disagreements between Lightning nodes. Yeah, maybe you can go into that.
Right. So for those who are not aware, dust is referring to uneconomical outputs. So if you have a output with, say, 20 Satoshis in it, even at the network rate of 1 sat per VByte, you cannot spend this output in an economical way because the input size to provide the script to spend that output is going to require more than 20 Satoshis to pay for it. So in Bitcoin Core mempool policy, we ban any transaction that has dust in it. This is not just a gatekeep, but it's also the idea of when you have dust in the global UTXO set, probably nobody is going to spend it, but everyone on the network has to keep that. And because scalability is essentially limited by the UTXO set size, it is like kind of an arbitrary choice by the Bitcoin Core developers to say we don't allow dust to propagate through Bitcoin Core nodes. But it's an example of that best practices thing that I talked about earlier in the slide, where, like, yeah, sure, it's consensus valid, and but it doesn't fit into the other categories of like DOS protection or whatever. But in a form, it is a DOS where you're asking the entire network to store dust in their UTXO set. And it's also an example of this kind of inherent tension between application devs and protocol devs when it comes to mempool policy. Because, for example, in Lightning, if you have outputs such as HTLCs in flight or the channel balance, such that like one of those outputs is dust, it's not going to propagate. And so I think typically in Lightning, if you have an output that is going to be dust, you just drop it. You drop it to fees. And that's considered the best practice. But this is an inconvenient thing that they have to deal with when they're implementing Lightning. And I'm trying to be as empathetic as possible. I understand why this sucks. But like, there's reasons to have that dust limit, and yeah, it's a place of tension there. Yeah. I'm not saying that it's never going to change. I'm just saying that those are the arguments.
So we need to wrap up. Thank you for your questions.
Thank you.